All right, class. Welcome to Network Management 1, one of the best courses that you could ever experience at Costa, CCNA, and today you're going to learn about subnetting. But before we start with subnetting, you got to definitely learn about the IP numbers, the IP version 4. We're going to be talking about that first before we go to IP version 6. And we're going to be talking basically about the whole concept of subnetting. All right, so what is subnetting? Basically, we're going to get into the binary conversion. So you will learn about dotted decimal notation. You will learn about the difference between class A, class B, class C. We're going to start with class C first. We're going to start with first class classful subnetting. And then before we even move on to that, we would have to talk about the conversion between binary and to decimal back to binary, which you can have some practice. And we'll talk about the base 10 and the base 2 representation in terms of place values. Stay tuned. All right, so we're going to talk about binary to decimal, and the first thing we're going to talk about is this binary number that is actually in 32-bit dotted decimal notation, but we're just using this 8-bit of it. We're going to talk about all the other bits that make up the octets, but we need to first understand the whole concept of binary to decimal. What we have here is place values. How do we arrive at these place values? And each one of these place values is going to be placed at the top of each one of these binary numbers for us to convert binary into decimal. But let's first talk about place values first in terms of how we arrive of base 2 representations of these numbers. Now, each one of these numbers here arrive at base 2 representations. So, for example, this is 2 to the power of 0, and any number to the power of 0 is 1. This one is 2 to the power of 1. Any number to the power of 1 would give you back that number. This here is 2 to the power of 2. As we know that from mathematics in primary school, 2 to the power of 3, 2 times 2 times 2, and so on, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and then 2 to the power of 7. And each one of these would give us the numbers when we multiply them together, and will give us the base 2 representation that will give us our place values. So this binary representation numbers here. So for example, if we were to look at the numbers and place them in terms of place values, this binary number here, and we also say that the first stroke is either 1 meaning on and 0 means off. All right, that means we're looking at the first bit on this side is going to be 1, which is on, then 0. Then 32 and 16, as in the place value, is on. Then 8 and 4 is definitely off. And then on and on for 2 and 1. So how do we convert this into decimal notation, which is base 10? So basically, 1 is on, so we're going to take the 128. I'm going to add it. 64 is off. 32 is on, so we're going to put 32 here. So we're not going to add 64 because 64 is off. Then we're going to add 16. So it's basically 128, 32 plus 16, right? Because both 32 and 16 is off. My bad. 8 and 4 is off, so we're going to just add the 2 and the 1. And when we add up all these numbers here, 128, 32 plus 16 plus 2 plus 1, we basically will end up with 79 to the base 10. All right? So basically, just to sum up again, this very first tutorial, we're talking about place values. All right? So the binary number 10110111, basically in place values here. And each one of these place values will be 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, and so on, 16, 32, 64. All you need to do is just to place these place values on top of the binary number, and you add up the ones that are only on, and you're going to get 79 to the base 10. So basically, some people will just say the decimal version is 79. We're going to talk about the whole concept of base 10 in a little bit. All we're discussing here basically is binary representation, converting binary to decimal. We're going to do another one, you understand, for you to understand, so to make sure that you could properly comprehend what we are doing. All right, so we're going to start another one to show you another example, and we have, of course, use our place values, which is the first thing that we're going to set up before we convert any binary to decimal, and the same thing we're going to use when we start to look at the 32-bit dotted decimal notation. We're going to talk about that during the period of this course, and so on. So let's go and do a very simple one. We're going to have the first 2 off. Then we're going to have 32 and 16 on, and then the rest is off, which is very simple for us to convert now binary into decimal. All right, so basically we're looking at 128 and 64, which is basically off. All right, so we have 32 that is on. So we're going to put 32 here. I'm going to just plus the 16 that also is on, the rest is off. So basically, we're going to put 32 plus 16, which is 48, again to the base 10. We could just put 48 because it's understandable that we whole concept about base 10. And as we talk about the whole concept of base 10 is basically numbering system, which is whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the base 10 representation. We could use back these numbers to build numbers to the infinity. Right? But this course is just basically based on base 2, and we're going to talk about a little about hex 2 as well. But again, this is another example of how we could convert binary into decimal. As you can see here, we put the place values first on top: 1, 2, 4, 8, 16, 32, 64, and 128. We already discussed how we arrive at the 1, which is 2 to the power of 0. We already discussed how we arrive at the 2, which is 2 to the power of 1, and so on. All we need to do is just to add the numbers to the 2 and 16, all right, which is the two numbers add on, and we will get 48, which is basically 40 to the base 10. So we have just successfully converted binary to decimal. Right, so let's take a look at our last example before you go on eClassroom and probably attempt some of these binary conversions that is on the classroom itself. And on the slide that you would see, there's a couple of ones. So I'm going to show you all on the slide where you could actually go and do some conversions to binary to decimal. All right, so what we're looking at basically is this 8-bit binary number, which is 111111011. Now, the interesting thing about this, of course, we already know if we have to add up all of them: 128 plus 64, which is on, plus 32, which is also on, plus 16 plus 8 plus 2 plus 1. The only one is not that is not on is 4, which is very easy for me because I don't even really need to add this up in my mind. This is basically 251. Now, how I arrive at 251, because if I had the 4 what is on, all the octets, if they are on, and I'm going to put it here, 1111 1111 will come up to 255. And as we know that the whole concept of 255, we'll talk about the whole idea of this the net mass, which is 255, 255, 255, and we go to the IP version 4 addressing scheme now. So basically, I just have to minus 4 here in this case, and I'll get 251. All right. In this case, it's easy because I have most of my numbers and them that are basically on. All right. Eventually, this will become like second nature for you in terms of addition of binary, converting binary to decimals. The next tutorial we're going to focus on is how to convert decimal to binary.